Right, I'm going to do something now that really we haven't covered in lessons, and it's called shifting. Now, we can shift bit patterns either to the left or to the right, and really in computing it just means multiplying or dividing by a power of 2. Now in the exam you'll pretty much just shift or you'll be given the number of places you have to shift it, which is fairly straightforward and simple. But as I said, I haven't covered this in lessons, so I will try to explain what is going on at the moment. I've put this sequence of numbers down and we've used it repeatedly in converting, but actually this sequence of numbers are just the powers of 2. So this here is 2 to the power of 0. This here is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. I think you get the idea here. It's just going to go up each time. 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. And that really is binary. It's just powers of 2. And I've put these numbers up here because we're going to try to understand what is happening when we shift things. So let's start with something really simple. We're going to multiply this number 2 times 4. Okay? So if I can represent 2 as a binary number and 4 as, well, how am I going to shift it? So let's first of all write this down as a binary number. So that is 0, 0, 0, 0, 0, 0, 1, 0. There's my 2. Okay? And I want to multiply it by 4. So when I'm multiplying, timesing means shift to the left. And, well, how far have I got to shift it to the left? Let's take a look at the number 4. And let's take a look at the index. I've got to shift it 2 places. So I'm just looking at the index above the 2 places. So it's here. I'm going to shift it 2 places. Well, that would take it from there to there. That's 1. That would take it from there to there. So if I put my 1 there and put zeros, so I'm shifting the whole thing along. So I've taken that number and I've sort of just moved it, shifted it left by 2 places. And you can see that what I've got now is 8. So 2 times 4 is 8. So that's the whole idea behind shifting. Shifting to the left is multiplying, shifting to the right is dividing. So let's do that again. Let's put my bit pattern here. 1, 2, 4, 8, 16, 32, 64, 128, and write the bit patterns above them. 2 to the 0, 2 to the 1, 2 to the 2, 2 cubed, 2 to the power 4, 2 to the power 5, 2 to the 6, 2 to the 7. And let's write down some sort of bit pattern here. Let's do this one, 1, 0, 1. Okay, and fill in the rest of the pattern with zeros. So what number have I got here? I've got a 32 and I've got an 8, so I've got a 40. I want to divide 40 by, or let's see, let's divide 40 by 2. Okay, so you should be able to do that in your head. The answer should be 20. But dividing means shifting right. So the whole bit pattern needs to move to the right. How far to the right does it need to move? Well, 2. Okay, if we take a look at the value 2, the index above it is 1. So I've got to shift the whole pattern along 1 to the right. So that's 0, 0, 0. That 1 goes to there. That 0 goes to there, that 1 goes to there, and then I've got noughts. So I've shifted the whole thing along right by 1 position because I was dividing by 2, and my answer is, well, I've got 16 there and I've got 4 there, which gives me my 20. So that's the proof that shifting right divides and shifting left multiplies. And that really is all you need to sort of know. There's a couple of problems. Let's say that we had a number like this. So let's write things down again. 1, 2, 4, 8, 16, 32, 64, 128. And I'm not going to put the indices at the top. That is a little bit confusing. I've done that so that you understand where it's come from. But let's say I had, again, a bit pattern like this. 5. So 4 and a 1 is 5. So I want to do 5 divided by 2. So that means I'm going to shift to the right by 1 place. And if I do that, I get 0, 0, 0, 0, 0, 0, because that is going to move to there, that is going to move to there, but where does that one go? Okay, and that's not the answer. So 5 divided by 2 is definitely not 2. Okay, it's 2.5. We'd need to extend this bit pattern in this direction. Now that is A level, not GCSE, so I cannot see this happening. But to be fair, they might ask you what is happening in the exam. They might expect you to know that you can't move beyond there because there is no next step here, not yet anyway. And the same thing is going to happen if I multiply by 2. So let's write down that pattern again. 1, 2, 4, 8, 16, 32, 64 and 128. Let's say I have this number 1, 0, 0. Let's make it really easy. So I've got 128 plus 1, so I've got 129, and I want to multiply that by 2, so I'm going to shift to the left by 1 place because I'm multiplying by 2. And when I write down my answer, well, this is going to move to there, so I'm going to put a 0 in at the start because there was nothing before it. My 1 has moved to there. And these zeros are moving in this direction, they're shifting to the left. But this 1 has shifted beyond the end of my sort of pattern at the top. But I can't say the same as I did here. I would expect at GCSE for you to understand what is going on here. And all we need to do is sort of just double this. 128 times 2 is 256, and now I've got the value 256 plus 2, which gives me 258, and if you multiplied 129 by 2, I'm sure you're going to get 258. So let's take a look on a calculator. Let's do that. Oh, that's nice. So I started off with 129, and I multiply that by 2, and my answer is 258, as you can see. So if I was shifting left, then I would continue this series on, doubling each time. If I was shifting right, in other words dividing, I'm going to ignore it. It does work, but but we get into sort of square roots and things like that. So for GCSE level, this probably will not happen. There could be a possibility of that happening, but shifting left and shifting right. And so one last thing I want to mention on this one is, let's just tick it over a little bit. Let's do our 1, 2, 4, 8, 16, 32, 64, 128. If I was going to multiply by 16, okay, any number, so if I've got sort of 5, which is 1, 0, 1, and I'm not going to put the zeros in this time because I want you to see the fact of shifting left. If I'm multiplying by 16, that's this value here. If I put that 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, I'm going to be shifting it 4 times. Okay, so here's my first one, 1, 0, 1, keeping the pattern, so that's my 1 shift. I'm going to shift it again, 1, 0, 1, that's my second shift. Shift it again, 1, 0, 1, that's my third shift. Remember, we're shifting it 4 times because 16 is 2 to the power 4, so the last shift puts me here, 1, 0, 1, and really I should fill in the rest of the spaces with zeros. 1, 2, 3, 4, 5, 6, 7, 8. So you can see how it's been shifted along 4 times to give me this number. So this number now is 64 plus 16, and 64 plus 16 is 80. So what did I start off with? I started off with 5 times 16. Let's hit the calculator again because I like things that are proven. So let's put it in. 5 times 16 equals, and there you go, 80. So that is shifting. It's multiplying and it's dividing, and you're just moving along by a particular number. I can't see them asking you to work this number out. It's not impossible, but I've shown you how it works. I've shown you how to shift and how to convert. Now that's probably the hardest thing I've taught you, but maybe one of the easiest things you can do on the exam. So you'll be told to shift something left 4 times. You can do that. Okay. You might be asked to shift something right twice. You can do that, and you can work out what the answer is. The only thing we've got to be careful of is if we fall off the ends at both places, at both ends. So that's shifting. Need to have a look at problems involving addition, and that should be it for binary.